Hey, all, it's Miss Johnson. Here's a video about what we kind of did in class today and what the assignment is this afternoon. All right, so we had two vocabulary words, two pretty important vocabulary words today. We had linear pair and vertical angles. So I drew the picture up here for both of them. Let's talk about it. Linear pairs are two adjacent angles, so angles that are next to each other, that add up to 180 degrees. And in this diagram, an example of a linear pair is like A and B, because they're right next to each other, adjacent, and A and D, also adjacent. We could have also said C and D and B and C. And then vertical angles are two non-adjacent angles, so across from each other, not next to each other, formed by intersecting lines. So for vertical angles, it has to look like this. It has to be like we're zoomed in on the X of two lines intersecting, and we're picking the two non-adjacent angles. So that's like A and C, they're across from each other, and B and D. We call these vertical angles. All right. And then we know a theorem about them, which is vertical angles are equal to each other. So A is equal to C. Let me get a better color. A is equal to C, and D is equal to B. That's the theorem, right? If we wanted to prove it, which I like proving stuff, so I do, we basically say that A plus B is 180 because they're linear pairs, and B plus C are also 180. They're also linear pairs, right? So if we wanted to give like the reasons over here, we would say that's the definition of linear pairs. Then we say, okay, if both of these are equal to 180, then it must be true that they're equal to each other. Instead of writing that English sentence that I just said out loud every single time, mathematicians have given that thought process a name. It's called the transitive property. So we get to say, because these two things are equal and these are equal to both of them, we just get to set these equal to each other. And again, if we want to give the reason, it's because of the transitive property. And now we kind of do some algebra 1 skills. We subtract b from both sides and are just left with a equals c. And then we're good because we wanted to show that a equals c, and we got there. So that is a finished proof. We can put this little box. It means finished proof, and we're good. But practically speaking, we get to use this theorem doing this kind of stuff. So this is what your assignment looks like. Let me put my stuff up here. Nice. I'm in the corner. Practically speaking, our assignment is we're given different diagrams, and we want to solve for x and solve for each of the angles. I'm going to do two examples right now. Here's my scratch work. Right. In the first practice example, we've got that angle A is equal to 20x minus 20, and angle B is equal to 8x plus 4. We know that A and B are linear pairs because they're right next to each other, and they add to 180. So we can say angle A plus angle B is equal to 180. And now we go back to last semester and we do some algebra, right? We're going to say 20x plus 8x is 28. Negative 20 plus 4 is negative 16. We can add 16 to both sides. And then we can divide by 28 and get that x equals 7. So I'm going to plug in x equals 7. Awesome. And now, to fill out the angle A, B, C, and D, I would just plug in x to each of these. So to get B, I would plug in x to 8x plus 4. And to get A, I would plug in x to 20x plus 20. So 20x, let's do 8x plus 4. 8 times 7 plus 4 is 56 plus 4 is 60. And then 20 times 7 minus 20 is 140 minus 20 is 120. And now we get to say, because they're vertical angles, angle A and angle C are going to be the same, right? These are equal, and these are also equal. So I just get to write for free that C is 120 and D is 60. Let me do this in a different color. Cool. So again, we started this one out. We knew two angles, and we knew that the relationship between those two angles was that they can add to 180. We set that up and then did a bunch of algebra. All right, next example, we've got a similar thing, but the two angles we know are vertical angles, right? They're across from each other rather than linear pairs. So when we set up our scratch work, we get to say that 9x plus 10 is equal to 100 minus 10x. Rather than adding to 180, we get to set them equal because they're vertical angles. And now I'm going to add 10x to both sides. Then I'm going to subtract 10 from both sides. And then I'm going to divide by 19. And honestly, this is a disgusting number. I should have made a better question. Let me get some stuff. 90 minus, or sorry, divided by 19. We get that x is like 4.73. All right. It actually rounds to 4.74. So we're going to do that. Now to find a, I just plug in this to our equations. We get 9 times 4.74 plus 10. We get 52.66. We could plug it in, but honestly, it's going to be the same thing because they're vertical angles for part C. And then to figure out B and D, we do 180 minus 52.66, right? And that's because of the linear pairs. Perfect. Let me start a little bit smaller. Perfect. So that's what your worksheet's going to look like. That's kind of the work we're doing today. We're just practicing knowing those definitions and using those theorems. All right, come to office hours if you need more help, or message me on Teams.